Hello everybody, in this video I will show you how to compute quartiles, lower fence and upper fence for a set of data using three methods. We're going to use the manual method, and we're going to use the box and whiskers method, and then the quartile inclusive method. So I have a set of data. This set of data represents the length of eruptions for a random sample of eruptions at the Old Faithful geyser in Calistoga, California. So I'm going to put this data in one column. The reason I put it in one column is because it's easier to work with. And second, most of the functions here work on columns as separate sets of data on Excel. So that's why we need to put one set of data in one column. And that's why we do it this way. If you have more than one set of data, then put it in separate columns, and Excel is going to treat it that way. So I will delete this question for now. The first step to compute the quartiles manually is to first sort your data from smallest to greatest. You don't need to sort your data from smallest to greatest if you're using Excel functions or using the box and whiskers method. So that is the advantage of Excel. So I'm going to select my column by clicking on the letter that is holding my column, which is in my case A. And then I'm going to go to the Data tab, and then from the Sort and Filter, and then from the Sort and Filter, I'm going to click Sort Smallest to Largest. I see it's not functioning properly, so I'm going to do it again. There we go. So now it is sorted from smallest to greatest. The minimum is 90 and the maximum is 120. So those are the first two numbers that I'm going to plug here. The first quartile that we can find is the median. Now, I'm going to show you how to find the median manually, and then we know we can find it actually using Excel, so we're going to double check. The steps: first, we sort our data from smallest to greatest, and then we find the number that is in the middle. To find the number that's in the middle, we're going to find the middle of our data. So I'm going to count my data first, how many numbers I have there. I have 44 numbers because we have an even number. That means the median is going to be two data sets in the middle. To find the rank of my median, I'm going to divide this by 2. So 44 divided by 2 equals 22. And I'm going to add 1 to that, so that's 23. So the two numbers, 22 and 23, are going to represent the two middle numbers. I'm going to find the average for these numbers, and then that will be my median. So here is number 22 and 23. The average is going to be 104. I could say my median, or the first quartile, the second quartile, sorry, is equal to 104. I know that is equal to the median, so I'm just going to compute the median using Excel, just to double check that I have the right answer. So that is the right answer. Basically, I just averaged the two middle numbers, which is the data value number 22 and the data value number 23. So this is the first step. So this is 104. Now that I know that the two middle numbers are 22 and 23, I know that this half of data, I'm going to change the color here to yellow, is one half of the data, and the other half is going to be, the other half, I'm going to change the color to, let me say green, is the other half of the data. So the first half of the data is yellow, the second half of the data is the green. To find the first quartile, that is the median of the first half of data. So the first quartile, Q1, is basically the median of the first half of data. Now, I need to find the first half of data. I have 22 data values here. The middle is going to be 11 and 12. So if you average these two numbers, you're going to get 101, which is the first quartile. So the first quartile is 101. The third quartile is the median of the second half of data. Again, I have 22. So the data value number 11 and the data value number 12, if we average them, we're going to get the median, which is the third quartile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those are those two numbers. 108 plus 109 divided by 2. So the third quartile is going to be equal to 108 plus 109, close the parentheses, divided by 2. So I add first and then divide. So the answer is 108.5. Okay, So this is how we do it manually, and this is the most accurate method. Now, to find the lower fence and the upper fence, we must find the interquartile range, IQR. IQR is basically Q3 minus Q1, which is the width of the box in the Bucks and Whiskers. The lower fence is the first quartile, Q1, minus 1.5 times IQR, or 1.5 interquartile ranges. Basically, the lower fence, any number that is below that number is considered an outlier. So if we have a number in my data that is lower than 89.75, then that number is going to be an outlier. If you scan here, the lowest number is 90. So we don't have an outlier from the bottom. So now we're going to compute the upper fence. The upper fence is Q3 plus 1.5 times IQR, which is 7.5. Enter. So the answer is 119.75. So the largest number, as you can see here, is 120. That means 120 is going to be considered an outlier because it's bigger than the upper fence. So that is if we do the work manually. Let me just double check my work here. So Q3 plus 1.5 IQRs, that's right. To find the quartiles using the functions on Excel, we know that the minimum is 90. We know that the maximum is 120. And we want to find the first quartile and the second quartile and the third quartile. So we're going to use quartile inclusive of the data, comma, it's the first quartile, so I'm going to click on the first quartile here and enter. The second quartile, I'm going to do the same, so quartile inclusive, select my data, comma, select number 2, which is the median value or the second quartile. And then the third quartile is going to be the same, so quartile inclusive of this, comma, the third quartile. And we know the maximum. So you see here the third quartile is slightly different from this third quartile, but it's very close. And I can find the interquartile range the same way, which is equal to the third quartile minus the first quartile. And the lower fence is going to be equal to Q1 minus 1.5 times IQR. The upper fence is going to be Q3 plus 1.5 times IQR. So as you can see, we still have that outlier that we're looking for. The reason why I'm using the inclusive method here, not the exclusive method, is because when you compute things manually and you use the exclusive method, your answer is going to be identical to the exclusive method only if you have an odd number of values in your data. But if you have an even number, just like I have here, then if you use the exclusive method, it's not going to be identical to the manual way. But the inclusive method, it's always inclusive of the median. So this is going to be consistent, and this is what we call the Excel method. That is what we refer to as the Excel method. The Excel method is the inclusive method, not the exclusive method. The exclusive method is similar to the method that we perform with the TI-84, but it only matches if we have an odd values of data in our data. It's not going to match when we have an even value, like in our case here. Let me show you. So let me use the data now to build Bucks and Whiskers. I'm going to select all of my data and then go to the Insert tab, go to the charts and choose from the histogram, drop down the Bucks and Whiskers. So here is the Bucks and Whiskers. If you click on plus sign and data labels, you will see that now those values are going to represent the values of the exclusive method. Let's compare them to the manual method. We have the maximum 120. Okay, that's right. We have the minimum 90. That's right. We have the first quartile 101, the second quartile 104, the third quartile is 108.70 5. Now, if we are not talking about an even number of the values, then those numbers are going to be identical. If this number is odd, let's say I have 43 data values instead of 44 data values, then these numbers are going to be identical. Now, to make this uniform and to make it the Excel method, I'm going to double click on the box. A dialog is going to show, and I'm going to choose inclusive instead of exclusive. Now that I have inclusive instead of exclusive, notice how I have the same numbers right here. 120 is an outlier. We know that because the upper fence is 119.125. So anything above that is going to be considered an outlier. Anything below 90.125 is considered an outlier. 90 is below that. The reason why we stick to that is because we don't want the inconsistencies of the exclusive method. So that's why we choose the inclusive method, because it's more consistent in Excel, and this is actually the Excel method that we're going to stick to. You will notice that all of your questions are using the inclusive method, not the exclusive method in your homework set. I consider the box and whiskers method the easiest method to find the outliers. I hope this video clarified why we're going to use the inclusive method, not the exclusive method. I hope this video showed you different ways to find the outliers. For the sake of being on the same page, all of your questions in the homework sets and your quizzes and your tests are going to use Excel method, which is the inclusive method. So practice using the inclusive method. You can use the function inclusive, or you can stick to the box and whiskers, which also gives you the outliers. That's a bonus. It's not going to compute the lower fence and upper fence for you, but it just gives you the outliers. You can find the lower fence and upper fence, and we have two different types of upper fence and lower fences. We have mild and we have extreme, and we are going to stick to the mild fence. If you are working with an extreme fence, then you're going to switch 1.5 in the formula into 3. That's the only difference between the extreme and mild. I will provide the formulas for you if I want you to compute lower fence and upper fence differently and find the outliers, the extreme outliers or the mild outliers.